All right, let's do the practice A quiz. Graph y equals 3 divided by x. So 3 divided by 1 is 3. 3 divided by 2 is 1.5. 3 divided by 3 is 1. 3 divided by 6 is a half. So this looks like that. Y equals the square root of x. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And y equals x minus 2 goes from through there, through there, through there. So this point is for 2 because I got square root of 4 is 2 and 4 minus 2 is 2. This point is 3, 1, because 3 divided by 3 is 1, and 3 minus 2 is 1. This point's a little tougher. That's where these two intersect, so I'm going to set 3 divided by x equal to square root of x, multiply both sides by x, and I get 3 equals x square root of x, which is x to the 3 halves. So if I take both sides by 2/3, the 2's and the 3's cancel, and I get x equals, see, 3 squared is 9, and 1/3 means cube root. And to find y, I'd put this value in for the x, and the square root of 3 to the 2/3 is 3 to the 1/3, or cube root of 3. So this point is cube root of 9, comma, cube root of 3. I believe that's correct. Okay. So, to find the area in here vertically, several people were doing the area under the top curve, did the whole thing. Then they took the minus the area under this one, and then minus the area under this curve. And that works. So we'd have the integral from cube root of 9 to 4 of the top one, which is the square root of x dx, minus the area under this one from the cube root of 9 to 3 of 3 over x, minus the area from 3 to 4 under the curve, that's x minus 2. So we've got, this is x to the 1/2 integrated, that's x to the 3 halves divided by 3 halves, which is 2 2/3, excuse me, evaluated from cube root of 9 to 4 minus, oh boy, excuse me, the integral of this is 3ln absolute value of x evaluated from cube root of 9 to 3 and also subtract, see, that'd be x squared over 2 minus 2x evaluated from 3 to 4. So the whole area would be this one. This would be the area under this part, and this would be the area under this part. So we get, if we put 4 in there, we get the square root of 4 cubed, which is 8 times 2 is 16 thirds minus, if we put the cube root of 9 in there and cube it, we get 9. And take the square root, we get 3 times 2 is 6 over 3, which is just 2. Then we have minus, and we got 3ln 3 minus 3 ln of, let's see, that's 9 to the 1/3. The 1/3 can come out using log rules, and this cancels. So that's just ln of 9. In fact, 9 is 3 squared, so the 2 could come out, and I'd have 3ln 3 minus 2ln 3, which is just ln 3 for all of this, minus 4 squared is 16 divided by 2 is 8, and minus 8, so that part is gone, minus 9 halves minus 6. So this is 4.5 minus 6 is minus 4.5 minus 6 is minus 1.5. This minus changes to plus, and this changes to 2. And this is 0, so this is minus 1.5. And that cannot be the area under this. So what did I do wrong here? I put 4 in there, I get 16 divided by 2 is 8, minus 8 is 0. Oh, yes, the area, this is 1.5, 1.5, and I've got to subtract it from the other areas. Okay, so that is correct. All right, so 16 thirds is 5 1/3, minus 2 is 3 1/3, so I have 3 1/3 minus 1 1/2 minus ln 3, which, let's see if I can find my calculator here. Let's just figure out what that is. 3 minus 1 is 2, and this is minus a 6, which is 1 5/6 minus ln 3. 1 plus 5 divided by 6 minus ln 3 is that number that we were getting, 0.0 7, 3, 4, 7. Okay. Now, going the other direction, I may have trouble here. So now if I'm going the other direction, I need to solve for each of these in terms of y as the variable and going up. So the first one, y equals 3 over x. If I multiply by x and divide by y, I get x equals 3 divided by y. That's this one. And for y equals the square root of x, if I square both sides, I get x equals y squared. That's this one. And for y equal x minus 2, I add 2 to both sides, and I get x equals y plus 2. Okay, so now I've got to find the area under the line, that's this way, minus the area under this curve in this part, and the area under this curve in this part. So the area under the line will be the integral, the line and we're going from 1 to 2 on the y's, from 1 to 2 of y plus 2 dy. That's all the area under the line, minus the first part, that's this part, from there to there. So that's going to be the integral from 1 to this point was 3, the cube root of 3 of that first curve is the 3 over y minus, and the area under the next one will be from the cube root of 3 to 2 under the square root one, which is going to be y squared. So this becomes y squared over 2 plus 2y, evaluated from 1 to 2. That would be all the area. And then minus this area, which would be this one, which is going to be 3ln cube root a y evaluated from 1 to the cube root of y, 3. And then we're going to have minus y to the third over 3 evaluated from the cube root of 3 to 2. So I'm going to get 4 over 2, which is 2 plus 4, minus 1/2 plus 2. That's the total area. Let's see what that comes out to be. It should be 1, 2, okay, it should be 1, 2, 3.5. See, that's 6 minus 2 is 4, minus 1/2 is 3 1/2. So that area came out right. Minus, and if I put the cube root of 3 in here, that's 3 to the 1/3. The 1/3 comes out and cancels that, so it's just minus ln 3. Oops, let's do it here. ln 3, and then I'll put a 1 in there, and ln of 1 is 0, so minus 0. So that's ln of 3 minus, and now we're going to have 2 in there, which is 8/3. And then if I put the cube root of 3 in there, it's 3 over 3, which is 1. And so I get 2 2/3 minus 1, which is 1 2/3. So I get 3.5 minus 1 2/3, or 1 2/3, which is 3.5, 1 minus 1 2/3. 3 minus 1 is 2, and then we got a minus a 6, which was 1 5/6 minus ln 3, which is the same value we had before.